Hello, you're welcome, so that you can solve this maths problem within the shortest time possible. So let's now start with our solution. So we have 5 to the power of k plus 2 is equals to 60. So we are asked to solve the value for k. So assuming that we have a to the power of m multiplied by a to the power of n, this one can also be written as a to the power of m plus n. So now here we shall have 5 to the power of k. So since it's addition, we shall multiply by 5 to the power of 2, which is equals to 60. So from here now we shall now have 5 to the power of k multiplied by, so 5 to the power of 2 is 5 times 5, which is 25, is equals to 60. So we want to remove this 25 on this other end. So now we shall now be forced to divide both sides by 25. Then also this side by 25. So 25 by 25 shall cancel. So now we shall now have 5 to the power of k. So 5 to the power of k is equals to 60 out of 25. So from here now we shall now find the common number, whereby when we divide all of them shall cancel without a remainder. So let's take 5. So 5 goes into 5 times. 5 goes into 20 to 60 12 times. So now we shall now say that our 5 to the power of k, so 5 to the power of k is equals to 12 out of 5. So let's now find a way of working it out properly by now removing the k. So assuming that we have the log of p to the power of m, this one can also be written as m the log of p. So from here now, 5 to the power of k, we want to introduce the log on this number. So now we shall now have the log of 5 to the power of k. So the log of 5 to the power of k, which is equals to the log of 12 out of 5. So since we've already worked out, or assume we have the log of p to the power of m, that represents the log of 5 to the power of k, we can write it in this form. That shall be now k log 5. So now we shall have k log 5 is equals to the log of 12 all over 5. So from here, the log of 12 over 5, assuming that we have the log b there over c, this one can also be written as the log b minus the log c. So in this case now, we shall say that k log 5, so k log 5 is equals to the log of 12 minus the log of 5. So we want to remove this k on this other end. So now we shall be forced to divide both sides by the log of 5. Then also the whole of this by the log of 5. So log 5 and log 5 shall cancel. So then now we shall remain with k. So now we shall say that our k here is equals to the log of 12 minus the log of 5, then all over the log of 5. So we don't say that this is the answer. Next we shall say that, so next we shall have something like our k now shall be, so we shall now use log 5 to divide both sides, log 12 and log 5. So now we shall have the log of 12 all over the log of 5, then minus the log of 5 all over the log of 5. So we shall now cancel the ones that are the same. So now our k is equals to the log of 12 all over the log of 5, then minus, so log 5 and log 5 shall cancel, we shall remain with 1. So let's now factorize log 12 all over the log of 5. So now our value for k shall be, so log 12 can also be written as the log of 3 multiplied by 4, then into bracket all over the log of 5 minus 1. So when you open the bracket, now our k shall be equals to, so now we shall be having the log of 3 plus the log of 4, then all over the log of 5 minus 1. So the next part now shall say that k is equals to, so now we shall divide both sides by the log of 5. So log 3 all over the log of 5, then also plus the log of 4 can also be written as the log of 2 to the power of 2, then all over the log of 5 minus 1. So the next one now shall now say that our k is equals to the log of 3 all over the log of 5, then plus So the log of 2 to the power of 2 can be written as 2, the log of 2, then all over the log of 5 minus 1. So here now we shall say that, assuming that we have log A all over the log of B, like this, log A all over the log of B, so this one can also be written as the log of A to the base of B. So taking this into consideration, our final answer shall now be, so we shall now have K to be equals to the log of 3 to the base of 5, then plus, so here now we shall have 2, then log 2 to the base of 5 there, then minus 1. So this one now shall now conclude to be our final and the most correct answer. So if you really loved how we've worked out this maths problem, don't forget to subscribe to our channel.